All right, we're looking at probabilities today using counting techniques from section 3.4C. We'll be doing combinations a lot in this, using combinations. All right, so in this first problem here, a warehouse employs 21 workers that are first shift. I'm right over here, 21 first shift. We got 17 on second shift. And then we've got 11 on third. All right, if I add that up, that's 49 total. Okay. 8 workers are chosen at random to be interviewed about the work environment. Find the probability of choosing exactly five first shift workers. Okay, so what we desire is 5 first shifts, which means if I'm selecting 8, that means I also have to have 3 second and third shifts. Okay, so that's what I desire. Now, how do I do that? All right, that means of the 21 first shift workers, I desire 5 of those. And that means of the 17 and 11, that's 28. Of the 28 other workers that are not first shift, I got to have 3 of those. Excuse me. And that's what's on the top for my desired. Now on the bottom is the total. And total, we have 49 workers. And total, we're selecting 8 total. And so this is how you set the problem up right there. We desire 5 of the 21 first shift workers. We desire 8 of the other 28 workers that are not first shift. That's what's desired. And on the bottom, we got 49 total. We're selecting 8 total. Okay? And then I just punch this in. So, punching this in. All right, I got 21 NCR 5 times 28 NCR 3, and then divide by 49 NCR 8. And there's my answer right there, 0.1478. 0.1478. I think the 8 would make the 7 go up to 8, so it'd be 0.147 in 3 places. Now what you could do is you could change it to a fraction, and this one don't go to the fraction very good, does it? Okay, well, there we have it. All right, let's go up to number 2 here. Same kind of problem here. All right, this time the warehouse employs 25 workers on first shift, 17 on second, and 11 on third. So we have 25 on first. We got 17 on second, and then we got 11 on third. Okay, which means we've got 12, 13, 1, 53 total. Okay. All right, now let's see what's going on here. 8 workers again are chosen at random to be interviewed about the work environment. Find the probability of choosing exactly 4 third shift workers. So what we desire here, 4 third shift, which means since I'm selecting 8 workers, I also have to have 4 first and second. 4 from first and second shift, which is not third. So to do that then, I desire of the 11 third shift workers, I desire 4 of those. And, so I've got to multiply here since I'm doing both of these. Of the first and second shift, let's see, first and second, there's, what is that, 42? Of the 42 first and second shift workers, I got to have 4 of those. See, 4 and 4 equals 8. Okay. So that's what's on top. On the bottom is my total, which in total there's 53 total workers, and I'm selecting 8 total. And there's how many ways you can do that. So there's how many ways you can do what's desired, and there's how many ways you can do the total. Now let's punch it in. Okay, so 11 NCR 4 times 42 NCR 4 divided by 53 NCR 8. And it comes out to be this right here. 0.04167. I think the 6 makes the 1 go up to a 2. 042 is what my answer will be on this one. Okay. All right, go to number 3. And similar type questions, so maybe get the hang of this real quick. This one has 28 workers on first shift, so we got 28 first. We got 17 on second, and 12 on third, which means we got 57 total. Okay. Now what are we doing here? Well, again, 8 workers are chosen at random to be interviewed about the work environment. Find the probability of choosing exactly 2 second shift workers and 2 third shift workers. Okay. So that means on my desire, I want 2 second shift and 2 third, which means that's 4. See, 2 and 2 is 4, and I'm selecting 8, which means the other 4, so it means the other 4 got to be what, first? They got to be first shift. Okay, so again, find the probability of choosing exactly 2 second shifts, 2 third shifts. That's 2 and 2, which is 4, which means the other 4 have to be first shifts then. That's what's desired. Now, how do I write that out? Okay, that means second shift, there's 17. So of the 17 second shifts, I desire 2 of those times. Of the 12 third shifts, I desire 2 of those times. And then of the 28 first shifts, I got to have 4 of those. And there's my top. That's what's desired on the top. On the bottom, there's 57 total. See, on the bottom is the total. 57 total, and I'm selecting 8 total. So this tells me how many different ways I can do that. And so this is my answer right there. Okay, just need to type it in. So 17 NCR 2 times 12 NCR 2 times, what was it, 28? All right, 28 NCR 4, and then divide by the total, 57 NCR 8. And there you go, man, 0.11122. 0.11122. If I keep my 3 decimals here, the 2 does not make the 1 go up, it stays. So 0.111. Okay. All right, now, number 4. Number 4, we got a different problem now, different kind of problem. A shipment of 11 microwave ovens contains 2 defective units. Okay, a restaurant buys 3 of these units. What's probably the restaurant buying at least 2 non-defective? All right, so here we go. There's 11. Make sure I got this on here where I can see it. There's 11 total microwaves, which means there's 2 defective, and that means there's got to be 9 that are okay, or not, or non-defective. All right, so What's probably the restaurant buying at least 2 non-defective units? They're okay. A restaurant's buying 3. Okay. Now, here's the thing. Here, this says at least. When this says at least 2, that means 2 or more. Okay. They're getting 2 or more non-defective ones. Okay, which means we got to do 2 separate things here, because we got to, that means there's 2 or they get 3 non-defective. Because see, they're buying 3. There's no way for them to get 4, so they're either getting 2 or 3, which is 2 or more. Okay, they can't get 4 because they're only getting 3. See, they're buying. This is they're buying 3. So they want 2 defectives, or they want 2 non-defectives, or 3 non-defectives. So there's 2 different things here. We're going to do both of these and then add them together. All right. So on the let's do the desired here. 2. I'm gonna put okay instead of non-defective. I desire 2 okay, which means of the 9 that are okay, we desire 2 of those times, and that means I've got to have 1 that's defective, since I'm getting 3 of them. So of the 2 defective, I desire 1 of those. I really don't desire it, but for this probability, I desire it. And on the bottom, the total, there's 11 total, and we're getting 3 total. Okay. So there's how I calculate getting 2 defectives. Then I got to do 3. So here's the 2. See, here's the 2 defective. Now I got to do 3 defective. All right. So on this one, 3 non-defective. I keep saying defective, but so that means of the 9 that are okay, I desire all 3 of those to be okay. And on the bottom, I got total, which is 11.3. Okay. And this is how I do the 3. So this is the probability of getting 2 defectives. Here's the probability of getting 3 defectives. I add these together. And I can push this all in at one time if you're just careful. Okay, so let me put this on here. All right, so I'm going to do 9 NCR 2 times 2 NCR 1 divided by 11 NCR, oops, too far, 3. All right, there's that one. Plus 9 NCR 3 divided by 11 NCR 3. And I get this right here, 0.94545. 0.94545, which if I keep 3 places, does the 4 make the 5 go up or stay? Well, it stays. So 0.945 would be my answer there. Okay. All right, number 5 here. 6 sales representatives. There's 6 sales representatives for a company chosen at random to participate in a training program. The company has 18 sales representatives, 3 in each of 6 regions. What is the probability that the 6 sales representatives chosen to participate in the training program will be from only 2 of the 6 regions? Okay. All right, so we have, let's do this. We got region 1, 2, 3, 4, 5, 6. All right, each of these has 3 representatives. Okay. Excuse me. So that means on here it says, what's probably that the 6 sales representatives that are chosen, they're going to select 6 sales representatives, and what's the probability that the 6 chosen are from only 2 of the 6 regions? So they're only from 2 of these. So what if they're from these 2 right here? Okay. So that means we've got 6 of those. So we desire of these 6, I guess we want all 6 of them. So of these 6, we want 6 of those. Okay. Now, here's the thing we got to do too. If I desire to be from only 2 of the 6 regions, well, it could be these 2, it could be these 2, and it could be these 2, or it could be 6 and 1, or there's different there's different ways you could do that. So of those 6, we're choosing 6. And when you have 6 choosing 6 on a combination, that's automatically 1. See here? 6 NCR 6 is just 1. So this 6 NCR 6 right here would be 1. But the thing is, there's 6 groups, and so that means of the 6 different regions, we desire only 2 regions. Okay? So of the 6 that are from the 2 regions we choose, we want all 6, which is just 1. So this here we can just leave it out and just say that's 1. But of the 6 regions, we only desire 2 of the 6 regions. Now on the bottom, we got total. And total, there's 18 total representatives, and we're selecting 6. And so that's what my probability would be. So it's going to be 1 times this, or just this, divided by that. So if I punch this in, 6 choosing 2, divide by 18 choosing 2. And it comes up to be this right here, 0.98039. And if I keep 3 places, the 3 makes the 0 stay. So 0.980. Okay, here's another one just like it. We'll do this one, and maybe that might help you understand what's going on again. So there's 6 sales representatives for a company to be chosen at random to participate in a training program. The company has 14 sales representatives, 2 in each of 7 regions. All right, so we got 7 regions with 2 each. What's probably that the 6 sales representatives chosen to participate in the training program will be from only 3 of the 7 regions. All right, so let's do that first. What we desire of the 7 regions, we desire all these representatives to be from 3 of the 7 regions. Okay? Now, in those 7 regions, let's just say that region 1 and 5 and 6. Let's say we got those. There's 3. I'm sorry. There's 2 in each one of those. Okay, there's 2 in each of 7 regions. So there's a total of 6. So of those 6, we desire all 6, which is just 1, so we don't have to worry about that. So there's what we desire on the top, and on the bottom is the total, which there's 14 total, and we're selecting 6 total. Okay, so let's type that in. We got 7 NCR 3 divided by 14 NCR 6. And there you go. 0.011655. If I keep 3 places here, the 6 makes the one go up, so 0.012. All right, so that's 0.012. All right. Number 7, find the probability of being dealt 3 clubs and 3 cards with 1 card of each of the remaining suit in 6-card poker. Okay, so in 6-card poker, that tells me on the total, there's 52 cards total, and I'm selecting 6. So that's what's on the bottom. Okay, now what's desired All right, we want 3 clubs. So that means of the 13 clubs that there are, we desire 3 of those. So that's how many ways we can get those. Then it says 1 card of each of the remaining suits. So this was clubs. So like diamonds, there's 13 diamonds, we desire 1 of those. And then the hearts, there's 13 hearts, we desire 1 of those. And then of the spades, there's 13 spades, we desire 1 of those. And there's all my desired. So we want 3 clubs, and we want 1 heart, 1 diamond, and 1 spade. Okay, and so punching this in. Okay, 13, choosing 3 of those, times 13, choosing 1 of those, times 13, choosing 1 of those, times 13 again, choosing 1 of those, and then divide by 52, and we're choosing 6 of those. And there you go. 0.03086. And if you keep 3 decimal places, the 8 makes the 0 go up, 0.031. Okay. Here's another one that's similar. Okay. What's the probability of being dealt 3 cards of one denomination and 1 of another in 4-card poker? All right, so since it's 4-card poker, then that means on the total, there's 52 cards total, and we're selecting 4 total. Okay. Now, this says, what's the probability of being dealt 3 cards of one denomination? That means like 3 sevens, or 3 tens, or 3 kings. Okay. All right, so what we're going to have to do is, there's 13 different kinds of cards. We have to select one type. That means we need to have a 7 or a 2 or a 3. Of the 13 cards, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. There's 13 of those. We got to have 1 of those. And then of those 4 cards of that kind, we want 3 of them. So there's 2 things going on with this one denomination. We got to get our one denomination of the 13 kinds, and then of those 4 cards, we want 3 of them. So like if we say 8, we hone in on 8. Well, there's 4 8s. We want 3 of the 4 8s. So 8 is 1 of the 13 kinds, and of those 4 8s, we want 3 of those. Okay. But then we want 1 of another. So that means of the remaining 12 kinds of cards, besides this 8 we've got here for this, or whatever that is, the first one is, we got to have 1 kind for that. And that means of those 4 cards, we have to have 1. All right, so there's a lot of stuff on the desired there. When you have these cards, you got kinds, and then you got the suit of the kinds. See, this is the kind, and that's the suit. All right, so that's what we have to do there. So 13 NCR 1 of those times 4 NCR 3 of those times 12 NCR 1 times 4 NCR 1, and then divide by 52 NCR 4. And there you go. Oh, that's 0.00921. Not very strong probability here. If I keep 3 decimals, the 2 makes the 9 stay. 0.009. Okay. And you can see that's not very likely to happen. If you're getting 4 cards and you're going to get 3 of just one kind, like 3 8s or 3 aces. That's not very high probability. Okay. Now the rest of these problems deal with this a bowl of 20 chocolate candies. Okay. A bowl has 20 chocolate candies consisting of 5 white chocolate, 7 dark chocolate, and 8 milk chocolate. So we have 5 white, we got 7 dark, and we have 8 milk, which comes up to 20 total. Okay? Suppose you reach into the bowl and randomly grab 3 candies. What's the probability that all 3 are white? What's the probability that all 3 are white? All right, so on the bottom, we can figure that real quick on the total. There's 20 total, and we're selecting 3 total. There's what's on the bottom. Okay, now on the top is the desired. What's desired here is, well, all 3 are white. So that means of the 5 white, we desire 3 of those white ones. And that would be it. So there you go, that's not too bad. So 5 NCR3 divide by 20 NCR3. Okay, and I think on this it wants a fraction. So it'd be 1 over 114. So 1 out of 114 times, so it's not very good probability. Okay, what about the 10? The bowl is the same thing. We have 5 white, we have 7 dark, we have 8 milk chocolate, which is 20 total. All right, this time, suppose you reach in the bowl and randomly grab 3 candies. What's the probability that all 3 are dark this time? All right, so the total on the bottom is going to be the same as the previous problem. Okay, that's my total. There's 20 total, we're selecting 3 total. But what's desired this time, we want 3 dark chocolates. We want all 3 dark. And there's 7 dark. So that means of the 7 dark ones, we desire 3 of those. And that's how you set that one up. So I'm going to go back to this problem here. And I'm just going to change my 5 to 7. And there you go, 7 over 228. Okay. The next one here, number 11. Same problem. 5 white chocolate, excuse me, 7 dark, 8 milk, 20 total. We're reaching in, we're grabbing 3 candies, just like, but here's what's different. What's probably that all 3 are milk this time? All right, here you go. Of the milk chocolate, there's 8 of those, so of the 8 milks, we desire all 3 of our candies to be milk. And on the bottom, we've got 20 total, we're selecting 3 total. Okay. So here's this one, and 14 over 285. Okay. Number 12. Okay. There you go. And it's the same problem. We've got 5 white. We've got 7 dark. We've got 8 milk chocolate, which is 20 total. Okay. All right, on this one, we're selecting 3 candies again. What's probably that 2 are white chocolate? Okay. Now this time, what we desire of the 5 white, we desire 2 of them. 2 of our candies we select to be white, which means that 3rd candy has to be one of these other 2, which there's 15 of those. So of the other 15, we have to have one of those. Okay, on the bottom is the total, and there's 20 chocolates total. We're selecting 3 total. So there's how that should turn out. Okay, so on this one I'm going to have 5 NCR 2 times 15 NCR 1 divided by 20 NCR 3. And change it to a fraction, which is 5 over 38. That's my probability right there. Okay. All right. Just a few more and we're done. 13. Same thing. There's 5 white chocolates, there's 7 dark chocolates, there's 8 milk chocolates, and there's 20 total. All right, we're selecting 3 candies. What's the probability that 2 are milk chocolate? All right, so this is kind of like the last problem. Of the 8 milk chocolate, we desire 2 of those, which means of the remaining of these other ones, there's 12 of those. Of the remaining 12 of the other kind, we've got to have 1 of them. If I'm going to have 2 milk chocolate, that means that third one has to be one of these other 2, white or dark. On the bottom, there's 20 total. We're selecting 3 total. And that's how you do it there. So 8 NCR 2 times 12 NCR 1 divided by 20 NCR 3, and that comes up to 28 over 95. Okay, 14. Same problem. We got 5 white. Oops. We got 7 dark. We got 8 milk, which is 20 total. Same problem. We're selecting 3, same thing. But here's what's different this time. What's the probability that 2 are dark? So that means of the 7 dark here, we desire 2 of those, which means that third candy has to be one of these other ones. There's 5 and 8, which is 13. So of the other 13, we've got to have 1 of them. And on the bottom, there's 20 total. We're selecting 3 total. So there's how you set it up. All right, so I think I'm just going to go up here and it's the same thing we did a while ago. Instead of that 8, it's going to be a 7. Oh, no. And the 12 will be a 13. Right, there you go. 91 over 380. Okay. The next one here, a bowl has 20. The same problem. We got 5 whites, 7 darks, 8 milk chocolates, 20 total candies. We're grabbing 3 candies at random. What's probably that at least 2 are milk chocolate? All right, got a little bit different routine here now. At least 2, which means 2 or more. And since we're grabbing 3, that means 2 or 3 are milk chocolate. Okay. All right, so if I get 2 milk chocolate, all right, that means of the 8 milk chocolate there are, we desire 2 of those. And that means of the 12 others, we got to have 1 of them. 23 total. All right, so this is how you do 2 right here. So there's 2, plus I got to do 3. All right, so that means of the 8 milk chocolates, I desire all 3 of them to be milk chocolate. And this will be 23 on the bottom. So there's how to get 2, and here's how to get 3. We add them together because it's 2 or more. So it says at least 2, which means 2 or more. So I do both of these, add them together. So you can type this in all at one time. I've got 8 NCR 2 times 12 NCR 1 divided by 20 NCR 3. All right, there's this one, plus, and now I do this one. 8 NCR 3 divided by 20 NCR 3. And there you go, change it to a fraction. 98 over 285. Okay. This will be the same thing. At least 2 are white chocolate, so that means 2 or more. Okay. I'm running short on time. I'm going to skip that one, okay, because I want to go to this next couple ones. This is number 17. It's the same problem. There's 5 white, there's 7 dark, and there's 8 that are milk chocolate, 20 total. All right, this one says you're grabbing 3 candies again. What's probably that none of them are white? There's no white at all. All right, so that means on the bottom now, there's 20 total, we're selecting 3 total. Okay, but since I don't want any white, I don't want any of these, that means they all have to be of these 15 here. So of those 15, we desire 3 of them because we don't want any whites. You know, we don't like whites, so we don't want them. So of the other 15, we desire 3 of those. So that's all you do for this. So 15 NCR 3 divide by 20 NCR 3, and then change it to a fraction, 91 over 228. 18 is the same kind of thing. We want no dark ones. So there's 5 white, there's 7 dark, there's 8 milk, there's 20 total. Okay, we don't want any dark, which means we don't want these, so we got to have 5 and 8. We got to have, of those 13, we desire all three of ours to be that. And there's 23 on the bottom. I'm not going to type that one in because I'm running short on time. Let's get to this last one. Again, there's 5 whites, there's 7 darks, there's 8 milks, there's 20 total chocolates. You grab 3 at random. What's the probability that you have 1 of each kind? That means of the 5 whites, you want 1 of those. Of the 7 dark, you got to have 1 of them. And of the 8 milk, you got to have 1 of those. And there's what you desire. On the bottom, there's 20 total. We're selecting 3 total. Okay, so as I punch this one in, 5 NCR1 times 7 NCR1 times 8, right? Yeah, 8 NCR1 divided by 20 NCR3. And there you go, 14 over 57. Okay, so that's doing probabilities with counting techniques 3.4C. If you have any questions, give me a shout. I'll help you all I can. All right, have a good rest of the day.